Thanks everybody. Welcome to our session. Today we will introduce some work about machine learning, GPU, and Spark, some things. Before we start the talk, does anybody hear about XGBoost? Okay, yeah, because XGBoost is widely used in the machine learning, and sometimes people say, okay, deep learning, TensorFlow, but most people forget, okay? XGBoost is much more popular than TensorFlow in real application. Meaning that if somebody joins the Kaggle like machine learning computation, and people found, okay, XGBoost in most cases is much better than TensorFlow some things. So today we will introduce how we can speed up XGBoost based on Spark and GPUs from different aspects. Before we start, let's introduce ourselves first. First speaker is Yanbo, and my name is Mingjie. We are from DataWorks. We focus on Spark and Spark machine learning and Spark ecosystem, TensorFlow something. This is our agenda, okay? First, we introduce our motivations, okay? What's XGBoost? Where's the bottleneck in the current XGBoost? What we can do there? Second, we want to introduce how we can use the GPU to speed up the XGBoost. And next, we introduce how we can do parallel XGBoost, meaning that we can use Spark to speed up the XGBoost model training and do some parameters like searching. Finally, we introduce some usage and demo based on the DataWorks HDP and all Spark and some future work. So XGBoost, I think most people maybe already heard about XGBoost. XGBoost is a gradient boosting tree algorithm. It's widely used in the different machine learning scenarios. I heard that, okay, most of data scientists like XGBoost. I asked them why, because they're easy. Low, you don't need to worry about how you can tune a parameter, you need to define some feature there. Because XGBoost is a tree-based model and gradient boosted model. It can learn the model and the cost function much better than previous algorithm like logic regression or some things. And other thing like XGBoost is developed by some PhD student in the University of Washington. He's very smart, and they developed the XGBoost in 2014. Today is 4 years later, but now XGBoost is still very, very popular in the machine learning. So currently XGBoost supports Python, R, JavaScript, C++ APIs. It can run on CPU and GPUs. It can run on single machine to multiple machine, Hadoop, Spark, Flink. Let's look at more about XGBoost. XGBoost is a tree-based model. You can think, okay, I think most people heard about a tree-based model. Yeah, okay, good. So tree-based model is different from the linear regression models. It means that we build a model like a tree. Means that, okay, when you have some data, okay, and your model like a tree, and for example, we have some scenario here, okay, we have some people, user, we have some training data there. We want to predict, okay, some people like computer games. You can go through the tree to make some prediction. You can say, okay, for example, we have some user like this old guy, okay, we can go through the tree to ask on each question whether his age is smaller than 15, what he's a male, okay. When you go to root leaf node, you can get the score. You can think about it, this is a kind of tree algorithm is widely developed, but the XGBoost is a little different on previous tree-based model. First, it's a gradient boosting trees algorithm. It means what? It wants we can think about it this way, okay? If we make some mistake, next time we want to learn from our mistake and then can make a better decision. Gradient boosting algorithms follow this logic. Means that first, he learn a tree, okay? And then apply this model to make a prediction. And then can get a result. And you can say, okay, what's a mistake I made? And the next round, he found, okay, you make a mistake, 5% error, okay? This time, I will reduce this error to 3%. Next round, and 2%. You can see this like run around, next round, next round. It's like iterationally get the much better trees. What's mean here is, it means this time to train this model is very complex, right? Because you need to do iteratively from one tree to other tree and other trees. So why XGBoost, you can look at the details of why XGBoost is so excellent. First, from the mathematics, use the second order the gradient for the loss functions. Previously, if you use the Newton or other approach, it is first order. Second, it have object function to reduce to constrain the tree. Means that sometimes we do machine learning, we have some bigger problem, is like overfittings. Means that, okay, even if your tree is very perfect on your training data set, but when you apply your model to prediction, result is very bad. So XGBoost applies the object function to constrain this tree size, the tree deep, it makes the overfitting not very bad. Third is a parallel tree construction. It means that when the XGBoost is developed, they consider, okay, how we can build the tree in parallel ways. So let's look at the XGBoost. So XGBoost, we can think it's a general machine learning like a pipeline, okay? First step, you need to train the model. You get some XGBoost model, right? And then you apply this model from test data to evaluate data, whether this model is good. Finally, you need to tune the model, okay? Because the tree, you need to still have some hyperparameter, like what the cost function you use, the tree size, or blah blah something. Or you need to tune your trees in much and better ways. So you can think, okay, what we can do here? What a Spark, what a GPU, what big data can help this? If the data size is small, everything is good. Okay, you can play on a single machine. Your data size is very small. You can put everything on memory. Okay. However, in real application, data is very big. I think everybody here is expert on big data. Big data size in most cases is gigabytes, right? You need a multiple machine to do some things. So we do first things, we want to use GPU and to parallel to speed up the trainings. You know, GPU is very fast for matrix computation. On the XGBoost, when you build a tree, they also have some matrix computation there. Second, we want to build the tree in parallel. Means that, okay, if we have some parallel computation model like a Spark, Flink, maybe Hadoop, okay, MapReduce, to speed up the training process to get the XGBoost. Second, okay, we want to evaluate the models. Means that when you tune the parameters, how we can get a better parameter to auto ML. Okay, this is not a Google's auto ML, but like how we can tune in higher parameters automatically based on Spark. Okay, because currently Spark is widely used in different applications like data analyze, OLAP, ETL, something. If we place XGBoost into the Spark ecosystem, and Spark can help XGBoost training the model. Secondly, if we want to place the GPU to help the XGBoost, we also can get a speed up. So in this talk, we introduced two pieces. First piece, how we can use GPU to speed up XGBoost model training. Second, we use the Spark machine learning pipeline to do model training and model parameter tuning. So this is our motivation, what we should do here. First, XGBoost on the GPU, distribute XGBoost, integrate XGBoost with Spark, and integrate XGBoost with Spark machine learning pipeline. Finally, we want, okay, for the data scientist, sometimes he don't know, okay, system issues. He just want you give me some interface. I can use it. I can train my model. I don't worry about the infrastructure. So we want, okay, run everything in Docker image and deploy on the Yarn, and Yarn can, okay, distribute the TensorFlow for you, XGBoost for you, and you can do the model tuning and the Spark something. Okay. For the end user, it's a much easier way to use XGBoost. So first piece of work is XGBoost on GPU. You know, the GPU is very good, okay, because people said, okay, GPU is very good for matrix computation, right? Because he feed data into block and block into GPU, and GPU can compute this more efficiently. So for the XGBoost, we can look at the two issues here. First, we have one tree here in the left side, okay? A, Y, N. Means that with some feature here, A, and you need to decide yes or no. For the next round, you need to choose, okay, how we can split the trees. So we can look at the procedure. Traditionally, you need to iterate to each feature or input data. And for each level of a current tree, you want best split values. And then you can find out, okay, the best split leaf load to split the tree. However, you can say if your tree is very big and your feature is very big, this is some big problem because you can see it's a two loop pairs. Two loops means that if you have like a millions feature and millions leaf load, this is a million multiply million. Okay, it's so bad. So what we propose here, like we use some previous works, how we can use XGBoost to speed up the trainings. Means that how we can search the best split point for the leaf. Means that give me a tree, okay, when we want to expand the tree, which leaf load is best to split, which feature we want the best to split. So we use prefix sum or radix sort operation to get the best split values. And based on some experience results, we found that XGBoost on GPU performance is much better than XGBoost on CPU. I think that everybody knows this. Yeah, and next piece, we want to introduce XGBoost on the Spark. Thanks, Yinbo. Yeah.
Thanks, Mingjie. Okay, and in the following session, we will talk about how to run XGBoost on Spark because Spark is a very good framework for distributed data processing. And if you have a lot of data sets that can't fit into one node memory, then you will need Spark for the pre-processing. Then we want to know whether XGBoost can run distributed and be embedded in the same data processing pipeline with Spark. Okay, this work is initially worked by Zhu Nan when he was pursued his PhD degree, and then we worked together to make better optimization to make it run more faster, more stable, and more easy to deploy. You can see these slides. There are a lot of raw data sources you want to processing, and Spark is a better way to ingest all the data source into the distributed data frame and to processing the raw data, like remove some duplicated data, remove some missing values, and clean some data. And so Spark is the best framework for ETL for data exploration and cleaning. After that, we want to train some models using machine learning algorithms, like Spark MLlab has provided some built-in machine learning algorithms. And in our proposal, we want to put the XGBoost, especially a distributed XGBoost, into the Spark machine learning pipeline and let users use it very, very easy. Let's first talk about the challenge when we want to put XGBoost into the Spark machine learning pipeline. Mainly are two challenges. The first one is to make XGBoost and Spark communicate in execution and memory layer, which means how to deploy distributed XGBoost meanwhile with Spark in the same cluster. And then we need to make them data exchange parallel in the memory layer. And another challenge is we want to do machine learning cross validation. We want to do like model persistence. We want to save the model and read the model back in another session. So we need to leverage the Spark machine learning pipeline infrastructure to help us. So when we wrap the XGBoost into the Spark machine learning pipeline, we should make it happen. Let's first reveal how distributed XGBoost works. So you can see the slides. There is one master. We call it a tracker or master tracker, and several distributed workers. This is what distributed XGBoost works. And actually, between the workers, they are synchronized via a Rabbit API, which can support it like our reduce. So what we want to do, we have a data frame, and the data frame is distributed across the clusters. And in each partition, we want to like it to talk with the XGBoost worker. So we should do data exchange between the Spark data partition and the XGBoost worker. And in the XGBoost workers, it will calculate some statistic information locally, and then we use our radius through the Rabbit API to synchronize the statistic information. And all this happens in the XGBoost work cycle, and we don't change it for anything for the Spark. And after that, you can see how we integrate Spark with the distributed XGBoost. The first thing is we need to start XGBoost tracker at the Spark driver side. You can say XGBoost driver here, it should be in the same machine as the Spark driver. And then at each partition, each Spark executor side, we need to start the XGBoost worker to make the XGBoost worker to processing the corresponding data partition in that in the data frame. So this is the execution layer. You can say we use first we use each Spark executor to start XGBoost worker, and then the worker will do work synchronized across all XGBoost workers. Spark executor don't need to handle anything. So this is also because currently the Spark executors and Spark RDD partitions didn't support any kinds of synchronized like our radius. But in the Spark community, we have a discussion to make it supported like our radius later. So maybe later we can make the implementation, make the XGBoost Spark integration more elegant. So another issue is you can say at each worker node or executor node, we need to copy the data from the Spark partition memory space to the XGBoost memory space. So currently we use a very ugly but can work well solution. You need to first copy the data to XGBoost GVM memory, and then we processing it on the XGBoost side. But a better way should be like we use some interchange data format like Apache Arrow to do the data exchange. It will make it very more faster. And currently in the community, we are making this improvement. Maybe in the later review, you can get this better improvement. Okay, for the second issue is how we make XGBoost running in the Spark MLlab pipeline, because the pipeline has a lot of facilities to help us do cross-validation, to model persistence. So in the XGBoost side, we will wrap two kinds of algorithms and models: the XGBoost as classifier and the classification model, regressor and the regression model. This is very, very similar to the currently Spark gradient boosting tree implementation, because Spark MLlab currently has Spark GBT classifier and GBT classification model, GBT regressor and GBT regression model. You just need to change the name, and all other things do need to handle. But maybe the parameter names is different. You should check the tutorial about the parameters to check which one should be the parameters you want to set. And another issue is how to handle the persistence, because for each XGBoost model, we need to store it into the file system and then load it back for model serving. So we have implemented the serialized format of the XGBoost, and then we can load it back. So this should be, we supported all the APIs in Spark MLlab, and you can change your code from Spark GBM to XGBoost in Spark. And you can say yesterday we just merged the Gen PR. The PR has touched almost 34 files in the current XGBoost repos, and maybe in the next release at the end of August, you can use this all of these new features, and it's very, very similar like the currently MLlab GBT. So you can also check the performance. The performance is the training time. The test was happened on 22 million data set. It's not a very big data set with 6 machines and 48 workers. So this is, you can say the XGBoost is 10 times faster than the MLab GPT classifier. But the memory use, maybe XGBoost still not very well, very optimized, because just we talk, currently we need to keep 2 copies of the data on each exact partitions. So maybe in the later reviews, later releases, we can do this optimized. So we are looking forward to this. Okay, let's see the demos. The demos will be uploaded to this GitHub. You can check it out later. Because the demos, the resolution is not good, so maybe you can. Okay. If you can't see it clear, you can come to front. The demos happened in Zeppelin. We started the notebook and read some code. This is code. First, we need to check the configuration of the Zeppelin because we use the Spark. Currently, all the code will run in the Spark session. You can say this is the Spark configuration. We need to do to configure the jar files. It's the third-party jar files. We built from the XGBoost repo, and we changed the exact cost and exact instance of number of the memories. It just want to make it run fast. The data is, this is not very big data. The data is the IRS data, very, very familiar for the data scientists or machine learning engineers. You can say, we can show the data set, and then we split the data set to the training data and the test data. 80% is the training data and 20% is the test data. After that, we will check whether the label is in balance because the original data is balanced, but we have split it. We can say it's almost balanced, and we can start it to train the data set. The next steps, we will construct a machine learning pipeline. It has 2 steps. The first step is we will assemble 3 columns of double value into 1 feature vectors, and then we fit the feature vectors into the XGBoost Spark integration, like the classification model of XGBoost. And then we need to also to index the label to convert the label from string to double and convert back after training. You can say this is the prediction result of the currently data set. Some of the data is training correct, and then the others may be not correct. So we can say the model evaluation result. After we have the model, we want to say the accuracy. You can say the accuracy is very, very good. This is because this is a very tiny data set. Okay, and so in the next step, we want to show the cross-validation because cross-validation is also very, very useful in the ordinary data science work. We will choose some data sets. You can say, in this example, we change the mouse depth and eta in the XGBoost parameters. We give some candidate of the 2 parameters and want to get the best model and the best parameters. You can say we use the cross-validation in this data set and running the cross-validation. You can say it will run 2 times 3, this means 6 models, and to choose the best models across the model accuracy. And then we will get the best models and the best parameters according to this model. This is, let's move forward. Okay, it's finished. Almost finished. Yeah, you can say we get the best parameters of the models, and then after that we can train on the whole data set, on the full data set. And we can also get the training summary of the XGBoost model. In each summary, in each steps, what's the loss function, what's the loss function of that steps, and the best parameters. You can say the eta is 0.6. We have set 3 candidates, but they help us to find the best one. And then we want to save the model to HDFS. You can say, and then we load it in maybe in another session for the for model training, for model serving. You can say we still did a prediction for the model and get the same result. This is a very complete machine learning cycle. Okay. Okay, maybe the demo is not very clearly because the resolution in the screen is not good, maybe. So you can check it at the GitHub and download the demos and all tutorials to reproduce this demo. So there will be some feature works for the XGBoost Spark integration. The first thing is we use Apache Arrow or ND4J to reduce the memory copy because currently we need to keep at least 2 copies in the executor node of the Spark to make XGBoost running. So in the later we will want to use Arrow to reduce the memory foot. And another option is we can run distributed XGBoost with GPU. Because currently the distributed version only supported the CPU. And another is in the Spark community, we are investigating for the barrier scheduling. The barrier scheduling is different from the currently Spark scheduling mechanisms. It will like a gun scheduling, and it can get, if you want to get all the necessary results, you can get all the results to start. You will not need to if you have 10 slots requirement. But currently, the results available is only maybe 6. So for the barrier scheduling, it will not scheduling job. This kind of job is like deep learning or XGBoost. Both kinds of jobs need to synchronize for all the executors. So if the results is not enough, you can, for the currently Spark scheduling, you give you 6 slots. You start the job, but the job will be failed because they need 10 slots and 10 executors to start it simultaneously. So the Spark barrier scheduling can give us new opportunities to integrate like XGBoost and Spark into the Spark pipeline. So this is the feature work for the XGBoost performance. And another issue is because we are data scientists, we are machine learning engineer. We're familiar with like linear algebra, like all kinds of machine learning models, but we don't want to handle too much system issues, like the features of failures of I/O, like install third-party libraries, because the XGBoost has a lot of dependency, like the Rabbit, like the communication between the nodes, different nodes. They use different protocols. So a better way is we deliver a good environment for the XGBoost running. So now currently Spark can run on Yarn, and Yarn can support Docker. So we can support it to deliver Docker image, which include all the necessary libraries for XGBoost and even for other libraries. And then we can run the Spark job, the Spark XGBoost integration job on the Docker image and on Yarn. That will make the words better, and it's very, very easy to use for data scientists. You just need to specify what kinds of Docker image you want to use. Okay, this is the reference. And do you have any questions? Okay, can you use the mic?
So the demo that you have shown in the Zeppelin notebook,
yeah.
Were you using the XGBoost classifier there?
Oh, yeah.
So is it in which version of Spark has XGBoost classifier? Because currently, I think the HDP 2.6.
Oh yeah. Currently, I think at the beginning of my demo, I have shown you need to add the third-party job files, which included XGBoost in the Zeppelin configuration. So
Okay.
in any kinds of HTTP version, you can use it.
Okay.
Yeah.
Thank you.
Yeah. Hi.
So are you communicating between each of the different partitions?
Yeah.
That's not a typical approach for Spark, is it? Isn't a typical approach if it's functional, you send it up in the executor, then it shuffles later?
Oh no. Actually, the communication between the XGBoost workers, they use a different way compared with Spark. They synchronize the data with Rabbit. It's a third-party library that XGBoost depends on. The Rabbit library can support the paradigm like all reduce, but Spark currently didn't support it. Maybe currently in the Spark community, we are investigate the barrier scheduling and following works which can make Spark native supported or reduce later, but currently we can't. Currently we use the XGBoost synchronized mechanisms, which is separate, didn't rely on Spark.
So just a follow-up question, sorry. I've been reading about TensorFlow on Spark.
Yeah.
So is that comparable? I mean, obviously you need to be able to have that exchange between executors and partitions in order to maintain the markdown chain of the network or whatever you want to call it, and be able to get the exchange of weights and do the epochs over and over, right? So is it a very comparable approach to what they're doing? Is it the same library? Is it a different library? Or do you know? Or?
Okay. Let me repeat your question. You means whether the separate synchronized mechanisms in XGBoost is comfortable with after communication mechanisms in the whole cluster, right? Yeah. This is really very good question because currently Spark, like Yarn, supporting all kinds of workload, and all kinds of workload has their own synchronized or communication mechanisms. For example, the Spark job uses their own synchronized communication mechanisms, and if you run XGBoost, they have a separate, like TensorFlow. If you run TensorFlow on MPI, it's also a different mechanisms. So there should be separate one that can work together in the whole Yarn cluster. Because in the Yarn clusters, there will be used container and Docker to isolate them. So that should be not need to handle by you.
Yeah, I think I can answer part of questions. So in here, the Spark, the main function of Spark is feed the data into XGBoost. And the XGBoost training data, when the XGBoost training the model, you don't worry about XGBoost. Means that, okay, when the XGBoost training for different partition, they communicate with each other directly. They don't rely on Spark. It means that, okay, they use a new, like a certain, like a MPI-based or like a Raptor-based approach to synchronize each other. It's different from the Spark communication way. Because you know Spark, when you like the training model, sometimes you need to synchronize all the parameters in a single node, okay? And in a single node, maybe your bottleneck. But for XGBoost and TensorFlow, you want to synchronize the parameter in different partitions at the same time. So use or reduce like an MPI-based approach to synchronize these parameters. It's different from Spark and TensorFlow. And currently, like XGBoost and TensorFlow, they want to use XGBoost on the parameter server way to get a better parameter. It's different from the Spark, the master load-based way to synchronize the parameter. Yeah, maybe answer your question. Yeah.
Any other questions? Okay.
Yeah, I have a question here. The patch for the XGBoost improvement is adaptable to any version of Spark?
It should be released in the next version, 0.8, and at the end of August or at the beginning of September.
Okay, but I mean whether it will work, has to work on Spark 2.3 or 2.4 or
Actually,
like...
it can work now, but maybe some performance is not good. But if we have included all the refactor of the patches, it will be run more fast.
Yeah, but that's the version for XGBoost, right? Not the Spark.
Yeah,
Okay.
yeah. The XGBoost 0.8 that will be released at the end of August is compatible with Spark 2.3.
Oh, okay. So now it cannot run on Spark 2.3, or
Oh yeah, it can also.
Okay, okay,
Yes,
yeah,
also can also. Yeah.
Thanks.
Okay. Okay.
So currently the GPT classifier, it doesn't support multi-class classification. That is part of the Spark ML GPT classifier.
You mean multi-class classification?
Multi-class classification,
Yeah.
the current Spark ML GPT classifier does not support it. So does XGBoost classifier
Oh
support
yeah, it's
multi-class?
supported.
You just support it, yeah.
Okay,
Yeah.
thank you.
Okay. Okay. Thank you for. Okay.
So I think that recently TensorFlow released the TensorFlow boosting trees. So it's also like another choice of the tree boosting. So will this become a competitor of the XGBoost, or they are using?
I don't think so. Because yeah, the TensorFlow also supported gradient boost for a long time, but it's not very easy to use compared with XGBoost, and it didn't include in the all the optimization that XGBoost compared with traditional gradient boost tree. So it's just the I think the Google's goal is just to make a gradient boost tree can running on TensorFlow, and it's not a very optimized implementation.
So it's more like a focus on the
Yeah, I guess so. Okay, thank you.
Thank you.